Now let's look at question number 19 of homework assignment number 1. Yeah. So for this question, I already gave you a hint video. So that analysis part, that information here, I do not repeat again. So if you want to get a better understanding for the analysis part, you can look at that video again. So here I talk about the solution part. Yeah. All right. So our goal, we want to find an element that is among top 7. So this is our goal. Okay. Yeah. And for this question, the main idea or method we want to use is the elimination method. The question is how to apply this method to solve the problem. Yeah. Okay. Yeah. So that's the most important part. Yeah. All right. So from this goal here, let's try to interpret this goal here. Yeah. What's the meaning? What property an element must have if it is among top 7? So let's ask question this way. Yeah. We need to find an element with this property. Yeah. So its value is in top 7. Yeah. So we want to interpret this goal in a different way. Yeah. All right. So let's say in this way, if so here let me use a few steps to interpret or to understand our goal. The first step, straightforward interpretation. Okay, all right. So if an element is among the top 7, okay, then the direct consequence or direct property it must have, then it must be greater than how many? Certain number of, so this question mark we need to answer. Certain greater than certain number of elements of the array. Okay? Yeah, so here n equals 352 top 7. Yeah. So if we draw diagram, suppose this diagram represents 352, then top 7. This part, top 7. So we want to find one among top 7. But what's the remaining part? Yeah. So 352 minus 7 equals 345. Yeah, this number. So this part, there are 345 elements. Yeah. Then this question mark is known. So the element in top 7 must be greater than 355 elements. Yeah, that's the only condition we need to, make this solution element satisfied. Yeah. The step one. Step two. How to find an element with this property. Implementation. So step two is the implementation. How to find an element. Yeah, because the solution may not be unique. So an element with this property. Okay, yeah. So here, greater than, we can interpret this greater than property as elimination. Yeah. Eliminate. Yeah. So eliminate. Eliminate 345 elements by comparison. Okay? Yeah. That's what we are going to do. Elimination method. Eliminate 345 elements by comparisons. All right. So how to find element with this property? So our step two, interpretation. All right. So we want to, the question, we want to find an element that is greater than 345 elements. Okay? Yeah. That's enough. Yeah. So given 352 elements, and we want to find one that is greater than 345 elements. All right, then we're done. Yeah. The question, how to do it? Yeah. So the last step, the critical step, the last critical step, how to find an easy way to do this. Yeah. So next step is how to find an easy way to do this. Okay? Yeah. The goal is clear, but the way. So when we choose a special way, we want to find a convenient way to make this happen. So that's the last step we need to do. Yeah. Last step, very important, the critical step. Okay, all right. Then, this last step, you need to connect to the minimum problem. You need to connect it to the minimum, finding the minimum. Minimum or maximum equivalent, right? Yeah. So here, if we need a maximum version, we just use the maximum version. So the minimum or maximum problem. Okay, yeah. We need to go back to our old experience, finding the minimum. The minimum problem, so here let's switch to the maximum version. The maximum solution, if you want to find the maximum of an array, you need n-1 comparisons. All right, so here we need to find the maximum. Maximum, yeah, here when you find the maximum, we want to find the maximum in the group, in the, selected group, in the group with 346 elements. Okay, yeah, because we know, yeah, the maximum, yeah, because here we use we use this fact. We use this fact. Max can eliminate 345 elements. That's what we need. That's exactly what we need. All right, max, yeah, because in a group with this many 346 elements, we find the maximum with 345 comparisons. And with this many comparisons, the maximum beat all the other elements in the selected group. Okay, selected group, we only select 346 elements from the given array. Yeah. We do not select all the arrays, all the elements. We only select just enough many elements in the given array. Yeah. So how many is just enough? This many, 346. This many elements is enough. Yeah. So after we select this many elements, then we apply our finding the maximum algorithm on it, and we get the maximum with 345 comparisons, and this maximum is greater than at least 345 elements in the array, and our conclusion, and this max element, so it's a partial max. You can call it. It's not a global max. Okay, it's not an absolute maximum. So it's a partial maximum. Okay, yeah. It only covers part of the elements. So it's a partial maximum. So not a global overall maximum. Yeah. So we find this element. It is among top 7. Yeah. Think about, yeah, all the analysis, solution, thinking, understanding in this question. Yeah. All right, yeah. So that's the question number 19.